Today we're hosting an international delegation who are here to see the world's first FuelFlex, an innovative piece of technology which has the potential to transform the way cement is made to make it more sustainable in a way that also makes sense commercially.
In 2017, we launched our development project on the FuelFlex pyrolyzer. And so we did a lot of initial work at our Dania test facilities in Denmark, where we did some pilot testing. When we were convinced that this was a good solution, I contacted Mannok and we had discussions on whether this would be a good fit for the plant here and that we would pursue this opportunity together. In 2018, we started the project, and now in 2022, we have completed the development, which means that it's taken 4 years. There's been a lot of challenges along the way, as can be expected when developing a new technology.
FuelFlex has already gained a lot of interest from the international cement manufacturing industry, with producers from Europe and now Korea making the journey to see the technology in action.
The key challenge for cement industry is the decarbonisation of the entire process. The focus of cement companies to date is in and around the displacement of coal with solid recovered fuel. Solid recovered fuel comes from the recycled waste industry, and it's a waste to energy under the waste to energy programme. The difficulty for cement companies is having the appropriate facilities to maximise the use of SRF.
Well, initially when we started looking at increasing alternative fuels to the calciner, we were looking at two previous designs. One was to increase the size of the calciner by building a new calciner. The second option on that was to build a COD, which was an external duct on the other side of the tower. But there was massive capital expenditure involved in both those projects. There would have been a lot of downtime required in the plant to do the connection. While we were looking at that, FLS approached us regarding a new concept for burning alternative fuels. So rather than using the bigger calciner and the COD, they had a new concept of using the FuelFlex to burn the SRF within the raw meal, rather than using the airstream and the increased size calciner.
The heat source we use for the FuelFlex to convert the waste into a reactive fuel is hot meal, which we already have in the process. So what we need to do is we need to mix this hot meal with the waste to get it to evaporate the water and to heat it up to convert it into gases and char. And that's a challenge because the meal is a solid, fine, cohesive powder. And to get it mixed, we've developed a new method of fluidizing the meal, whereby we get this fine, cohesive powder to flow like a liquid. And that's needed to be able to effectively control the process when we mix the waste with this hot meal to make this energy efficient fuel for the cement process.
Personally, I think it's a game changer for the cement industry because it's a relatively easy add-on for massive gain. It's a low capital cost installation. It can be built in the tower while the plant is running. This was all constructed during runtime, and with very relatively short downtime required to connect into the main system. Plus the fact that we can switch it off, isolate it, and run the plant as normal if need be.
The FuelFlex pyrolyzer is a significant development in the global cement industry, and it's a significant development because it reduces the baseline nitrogen oxide emissions which we get from cement plants, which means that less plants will have to use ammonia water to reduce the NOx emissions to reach a certain level, whereas the situation until now has been that plants would need to use selective catalytic reduction, so catalytic solutions, to get to such lower levels.
We need to reduce our CO2 emissions. We need to reduce a lot of emissions from the plant. The reactor should reduce our CO2 emissions by 58,000 tonnes per annum. The NOx reduction, which was something that was a big add-on that we weren't expecting at the very start, but we've seen the benefits of it, and I suppose that has been the key reduction in our emissions, has been the ammonia water being required to keep down NOx. So when the reactor's running there, we're running maybe 20% lower than what our NOx limit is in our license. So that only can have huge benefits for the environment and our sustainability.
The initial goals for us for the FuelFlex was to have over 80% substitution of our coal on the calciner side. But I think when we have this thing running well, we'll have 100%.
The FuelFlex pyrolyzer has two main safety benefits associated with it. The one safety benefit is that you avoid using ammonia, and ammonia is a hazardous chemical. The other part is that for maintenance, then you need to clean out buildups, and so before you can do work, you have to put scaffolding inside, and there's a lot of work and safety aspects of making maintenance on a large calciner. So a smaller calciner reduces the associated safety issues.
The whole FuelFlex system is a much smaller, concentrated piece of kit in the system, so it's much reduced level of permissions necessary or changes to the process are minimal, but also planning permissions that would become necessary with a large-scale calciner are no longer required, because this equipment is very self-contained and really has no other visual impact on the plant.
It was a brave decision by Mannok to join FLSmidth on installing and developing an unproven technology. But I think there have been benefits in it for both sides, and we have had a long, good, trustful relationship, which is what is needed for being successful with such a project.
Working with FLS on the project over the last 3 years is very significant from a developmental point of view, I feel, as well, for our people and our organisation. We had not been involved in any large-scale research and development or prototype deployment of this nature previously. So we learned a lot in the process. We learned a lot about international collaboration on a large-scale research and development project. I think it has assisted our team in developing their skills in research and development, and I think it's given them a much greater understanding of what's involved in deploying something which is very, very new, which requires continuous refinement and a lot of input from many third parties, academic institutions, specific design and engineering organisations in many parts of the world. So we've learned a lot about that, and I think it's given us a lot of encouragement to further that approach in future projects.
Because this is the world first of this kind on the preheater, inevitably there's going to be challenges, and I think we've done very well in collaboration with the FLS to solve the problems, to overcome any obstacles that we met along the way. The FLS team are extremely professional and have been extremely professional the whole way through this. We've worked with some great people on the site here. There's some great people working back in Copenhagen on this, and anybody that's looking to reduce their carbon emissions and increase their alternative fuels substitution have to seriously consider installing this piece of kit.
There's no doubt that the adaptation of the system will have a significant input on the cement sector, because it will accelerate the move to more and greater levels of coal displacement, and it reduces the cost of doing so practically in every cement plant that is not running the system today.
It feels great to have come to successful completion with such an ambitious project here, and I really feel that it really relies on so many people's efforts, capabilities and insights, and not least the will to follow through and make this successful.
Our friends in FLS we've been working with them now. I've been working with them personally almost 30 years. So obviously we've all created bonds with these people that we've been working with for so long.
We're very pleased to have been involved with FLS in providing leadership in this very important space for ourselves and for the sector. It's a world first in terms of the deployment of the technology and is a significant game changer, we believe, for ourselves in reaching our own carbon reduction targets, but we also believe for the industry.
My message to Mannok, to everyone at Mannok who's been involved and everyone in FLSmidth who's been involved in this project, it's a big thank you for the contributions each and everyone has made, and without all these individual contributions we wouldn't have been where we are today.